In this universe, silence is the ultimate trick. We look up at the night sky, seeing stars twinkling peacefully, and we assume space is a quiet, safe place. But the truth is, we are staring into a cosmic graveyard. Every single star you see is sentenced to die. But in space, death is not the end. It is the beginning of something far more terrifying and far more beautiful than the human mind can comprehend. On our journey today, we will not talk about the stars we know. We are diving into the darkness to face the ghosts of the cosmos. Stars that refuse to die, stealing life from their neighbors. Dead corpses that tick like atomic clocks. And magnetic monsters capable of ripping atoms apart from thousands of miles away. Prepare yourselves because you are about to see the other face of the universe. To understand these monsters, we must start the story right here, with the source of our life, the sun. This giant ball of plasma burns 600 million tons of hydrogen every single second to give us warmth and light. It exists in a perfect balance between gravity crushing it inward and nuclear explosions pushing it outward. But fuel is not eternal. 5 billion years from now, the hydrogen in the core will run out. And then the final battle begins. Gravity will temporarily win, crushing the core and raising temperatures to insane levels. The outer layers will expand hundreds of times. Our gentle sun will transform into a red giant. In those days, the sun will swallow Mercury and Venus. And Earth? Our blue skies will vanish. The oceans will boil and evaporate into space. Mountains will melt like wax. Our beautiful blue planet will turn into a hellscape of molten rock before being swallowed or scorched forever. A tragic ending, isn't it? But wait, because true beauty is born from this destruction. After the red giant expands, it can no longer hold on to its outer layers. It gently sheds its skin, pushing gas and dust into deep space in a breathtaking artistic display. This is what we call a planetary nebula. They're not planets. They're the shrouds of dead stars, glowing in rainbow colors, where each color represents a different chemical element cooked by the star over its lifetime. But what remains in the center? Look closely at the heart of the nebula. That tiny white dot is the corpse of the sun. We call it a white dwarf. Imagine a mass equal to the entire sun, crushed and squeezed into a ball the size of Earth. The density is unimaginable. A single teaspoon of this white dwarf material would weigh a whole ton on Earth. The white dwarf is a hot jewel, glowing with heat stored over billions of years, slowly waiting to fade away forever into a black dwarf. This is the quiet death that awaits our sun and most stars in the universe. However, not all stars go quietly. Elsewhere in the galaxy, there are stars that refuse to die and decide to steal life by force. More than half of the stars in our galaxy are born in pairs. They are twins, locked in a gravitational dance, circling each other for billions of years. But what happens when one of them dies before the other? Imagine a system where one star has already aged, died, and become a dense white dwarf. Its companion, however, is still alive, entering its swollen red giant phase. The dead star is small, but its gravity is intense. It lurks in the darkness, waiting for its partner to get just a little too close. And when it does, the romance ends and the cannibalism begins. This is what astronomers call a vampire star. The dead white dwarf begins to strip the outer layers of hydrogen from its living companion. It siphons the gas like a cosmic parasite. You can see a bridge of superheated plasma flowing from the living star to the dead one. The stolen gas doesn't fall directly in. It spirals around the white dwarf, forming a glowing ring called an accretion disk. It looks beautiful, but it is violent. The friction in this disk heats the gas to millions of degrees, causing it to shine brighter than the stars themselves. The white dwarf is greedy. It eats and eats and eats, becoming heavier and more unstable with every sip of stolen fuel. But in the laws of physics, greed has a price. There is a limit to how much a dead star can eat. It is known as the Chandrasekhar limit. Once the white dwarf reaches a critical mass, about 1.4 times the mass of our Sun, it can no longer support its own weight. The core temperature spikes. The carbon inside ignites instantly. The star essentially becomes a nuclear bomb the size of a planet, in a fraction of a second. A Type 1, a supernova. The explosion is so bright that, for a few weeks, this single dead star can outshine an entire galaxy of billions of stars. The vampire star is completely obliterated. It is torn apart, scattering iron, nickel, and calcium into the universe. The thief is gone, but its violent death has just seeded the cosmos with the building blocks of life. This explosion was massive. But believe it or not, in the grand scale of the universe, this was just a spark. Real terror comes when the biggest stars in the universe, the supergiants, decide to end their lives. When they collapse, they don't just explode. They tear a hole in the fabric of reality itself. The explosion of a white dwarf is powerful, but it is nothing compared to the death of a true cosmic titan. Meet the supergiants, massive stars, 20, 30, or even 50 times the mass of our Sun. They live fast and they die young. While our Sun burns its fuel slowly over billions of years, these monsters burn through their tank in just a few million. Inside the core, a desperate alchemical battle is taking place. Gravity is trying to crush the star, and the star fights back by fusing heavier and heavier elements. It fuses hydrogen into helium, then carbon, then neon, oxygen, silicon. But eventually, it creates something that spells its doom. Iron. Iron is the cosmic poison. Fusing it doesn't create energy, it consumes it. The moment iron fills the core, the engine stops. The fire goes out, and gravity, which has been waiting for millions of years, finally wins. In a fraction of a second, faster than you can blink, the core collapses inward at 25% the speed of light. It slams into itself with such force that it rebounds outward. Supernova. A shockwave of pure energy tears the star apart. The outer layers are blasted into the void, creating a nebula that will shine for thousands of years. When we look at the Crab Nebula today, we are looking at the grave of one of these giants. But amid the wreckage and the colorful dust, something survived. The core didn't disappear. It was crushed so hard that protons and electrons were smashed together to form neutrons. Ladies and gentlemen, behold the Neutron Star. This is not a star as you know it. This is a city-sized atomic nucleus. Imagine taking a star larger than our Sun and squeezing it into a ball the size of Manhattan or London. It is only 20 kilometers wide, but the physics here are broken. It is the densest object in the universe, second only to a black hole. Remember the white dwarf? Hautishti. A teaspoon of it weighed a ton. Well, a teaspoon of a neutron star weighs 1 billion tons. That is the same as mounting every single human being on Earth onto a single teaspoon. Gravity here is 200 billion times stronger than on Earth. If you were to drop a marshmallow on its surface, it would hit with the force of a nuclear bomb. But the most terrifying thing about these stars isn't their weight, it's their speed. They are dead, but they are spinning. When a massive star collapses into a neutron star, something incredible happens to its rotation. It is the same principle as a figure skater pulling their arms in to spin faster. The star, which used to take weeks to rotate once, now spins at terrifying speeds. Imagine a sphere the size of a city, spinning on its axis 30, 100, or even 700 times every single second. At this speed, the surface is moving at a significant fraction of the speed of light. If you stood on the equator of this dead star, you would be whipped around the planet 700 times before you could take a single breath. This violent rotation transforms the neutron star into one of the most useful and dangerous objects in the sky. We call them pulsars. Pulsars are highly magnetic. They blast twin beams of radiation and radio waves out of their magnetic poles. Because the star is spinning, these beams sweep across the universe like the light of a lighthouse in a dark ocean. We on Earth cannot see the star itself. We only see the flash. They're the most precise clocks in the universe. Some pulsars are so regular that they rival our best atomic clocks. If a pulsar arrives 1 millisecond late, we know that something massive, like a gravitational wave, has disturbed it. While pulsars are defined by their speed, there's a rare breed of neutron star defined by its anger. Meet the Magnetar. It looks like a normal neutron star, but it hides a terrifying secret. Its magnetic field is 1,000 trillion times stronger than Earth's. This is the most powerful magnet in the known universe. To understand this power, imagine this. If a magnetar floated halfway between Earth and the Moon, it wouldn't just mess up your compass. It would wipe every credit card on Earth. It would pull the iron out of your blood. And if you dared to get closer, say, within 1,000 kilometers, the magnetic force would be so intense that it would literally tear your atoms apart. You would dissolve into a cloud of monatomic gas instantly. But the real danger isn't getting close. It's what happens when a star gets angry. The crust of a magnetar is under immense strain. Sometimes it cracks. We call this a starquake. When the crust snaps, even by just 1 centimeter, it releases a blast of energy greater than what our sun emits in 100,000 years. In 2004, a blast from a magnetar 50,000 light-years away hit Earth. Even from that incredible distance, it was strong enough to ionize our upper atmosphere and blind our satellites for a moment. If that star had been close, say, 10 light-years away, our ozone layer would have been destroyed and mass extinction would have followed. Thankfully, they are rare. They're the sleeping dragons of our galaxy. From the gentle death of the white dwarf, to the cannibalism of vampire stars, to the terrifying power of magnetars, the universe is far more violent than we could ever imagine. But remember this, without these deaths, we would not exist. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all of it was forged in the hearts of these dying stars and scattered by their explosions. We are not just observing the universe. We are part of it. We are made of stardust. And perhaps one day, when our own sun dies, our atoms will be scattered once again to become part of a new star, a new planet, and maybe new life. Thank you for watching.